Hello everyone, welcome back to Chemistry CC for you. So it's been a long time, I know, and I have been receiving a lot of requests to make some solutions for the Cusat Cat PG chemistry question. So I thought even if I'm not making it regularly, I can make a few videos where we are solving some questions, and our strategy even after an year remains simple, where we are solving more questions to cover more concepts. So without wasting much time, let me start with the first question. So the very first question here is for a reaction with an activation energy of 49.8 kilojoules per mole, the ratio of rate constants at 600 and 300 Kelvin are given, and the R value is also given to us, and we need to find the ratio of this rate constant. So Kelvin, the temperature is given. So we know that in our case, let me take a pen over here, the activation energy or the EA is given, which is 49.8. And the formula that we are going to use here is the Arrhenius formula, which is K equal to, the rate constant is equal to A e raised to minus EA by RT. And we need not know the value of A, because all they are asking for is the ratio. So in the ratio, the A value remains the constant and it gets cancelled out. So since it gets cancelled out, we need not worry about that value. So let's remove this exponential term. So in order to remove the exponential term, we have to convert it into the ln format. So ln k 600 by 300 will be EA by R 1 by 600 minus 1 by 300. You know, this is a very simple rearrangement happening over here. So it is easy for you to understand. From here, it is really simple, wherein we are just substituting the value of EA as we have minus EA by, sorry, I did not include the negative over here. So minus EA by R, 1 by 600 minus 1 by 300. And while giving the value, we have 49.8. And since our value is in kilojoules, we need to convert it into joule. For that, we are adding into 10 to the power 3. The value of R is given to us. The temperature is already substituted. Once you solve that, you will get the value of ln K 600 by K 300 as 10. But our final answer is not to find the value of the logarithmic form, but rather the ratio. To remove this, we will convert this back into the exponential form, and our answer will be option D, e raised to 10. So basically here the idea that you have to keep in mind is about the Arrhenius equation. And if you create the ratio, you have to convert the exponential into the ln format, and then we are converting it back into the exponential format in order to get the answer. Okay, let's move forward to the second question now. Here again, I have chosen a question from thermodynamics over here, because physical chemistry, a lot of numerical problems arise in all the examinations. So we'll start with some of these problems and we'll go to more complex ones in the coming days. So this is a question about the Carnot engine. So the Carnot engine low temperature reservoir is given, and the efficiency in the initial efficiency is given, and we are given a problem that the efficiency is now increased to 70%. So how much is the high temperature reservoir's temperature is changed? So the only formula that you need to know over here is the efficiency formula, which is 1 minus T cold by T hot into 100, where T cold is the low temperature reservoir's temperature and T hot is the high temperature reservoir's temperature. Substituting the first part of our question, which is, while the 50% efficiency is there, we can write that 50 by 100 is equal to 1 minus T cold by T hot. So the T cold temperature is already given to you as 300 Kelvin. Substituting this, our T hot value will be equal to 600 Kelvin. After that, we are substituting eta is equal to 70%, and resubstituting this again, we will get our new T hot temperature as 1000 Kelvin. As you can see, I somehow by mistake, I have put this in the other region of the slide. But as you can see over here, if you solve for this question, same formula two times we are substituting. First in the case of 50% efficiency, and second in the case of 70% efficiency. Second time we get the value as 1000 Kelvin. But our answer should not be 1000, because the question you have to read again. The question is how much it should be increased. So the difference, the delta TH is what we are asked to find. So the first TH, after the increase in the efficiency, the temperature is 1000 and the initial was 600. So we can get the delta TH as 400 Kelvin, and that makes our answer as option A, 400 Kelvin. Hope this is okay for you. So one formula and you got the entire answer. Now to our next question. This is a very fun question. I was very glad to see that this type of questions are being asked. So all altruists gladly make gum in gallon tanks. The C2 epimer of D-glucose is. So for that you need to know you need to have an understanding of what epimer is. So epimer is when the position of hydroxyl group or the OH group, only one OH group is being altered. So this is actually given for remembering all the different forms of this glyceraldehyde. Will give erythros and thrios. From that we get ribose and arabinose, and we have so many of the classification. Finally we have the allose, altrose, glucose, mannose, glucose, iodose, galactose and talose. And this kind of this particular representation is the one that we are looking for in order to understand the epimers. So if you are starting to number them, it will be the C, this will be 1, this will be the 2. So C2 epimer, when it is hal, this is the structure of glucose. And D mannose, if you look closely, D mannose is the one where the OH group is altered at the C2 position. Galactose is very similar, but in galactose, the only problem is that if you look at the structure of glucose and glucose and galactose, it's a C4 epimer. Sorry, I think I made a mistake over here. Anyway, let's come back to this. In the case of mannose, glucose, the positions are altered only in the C2 position. Other than that, it looks exactly the same. So is that fine with you? And I hope this particular chart, if you are able to memorize, very easy for you to answer any of these kinds of questions. And I hope you will be able to answer more number of questions. And I think we have made a video sometime back giving all the shortcuts to remember this. Maybe I will repost that in the comment box or in the description box below. Please go through that and let's continue with our questions now. Among the following photophysical processes, which one is non-radiative process? So I'm giving you the answer in the very beginning. The answer is in the system crossing. Now why is it so? For that you need to understand what are non-radiative processes. So non-radiative processes are basically transitions between electronic states when there is no photon emission. So many such processes are there, like fluorescence, phosphorescence, etc. are accompanied along with the emission of photons. And prompt and delayed fluorescence are similar, but the basic idea in those are the process of the phenomenon of fluorescence. Just let us take a look at what each of these are, because the next time the questions might not be on the photophysical process. It might be in any non-radiative process or radiative process. Let's just take a look at it so that you can prepare this part and just move on with this. So prompt fluorescence is the photon is immediately emitted upon the relaxation of the excited state. Delayed is very similar, but there is a delay between how the excitation and emission happens because of some relaxation method. And phosphorescence, like you know, it is from a triplet excited state to a singlet ground state, and it has a longer lifetime compared to a fluorescence phenomenon. And this image shows you the entire fluorescence and phosphorescence phenomenon. And you can see singlet to the singlet excited to singlet ground state is the fluorescence. In the system crossing is within the states, like singlet to triplet excited state it is there, and triplet excited state to another triplet excited state is internal conversion, and triplet excited state to singlet ground state is the phosphorescence. So you should be able to make out all these using this particular figure, and the energetics of that are also given. Memorize this to answer more questions from this particular part. Next question is something just to mix it up a bit. I have taken a question from the inorganic chemistry part where the crystal field splitting energy of a tetrahedral cobalt tetrachloride is given as 8,000, and we need to find in COCl6 4 minus what it would be. And the equation, as you know, is very simple. It is delta T is equal to 4 by 9 of delta O. Once you know this, it's a direct substitution because delta T is already given to you as 8,000. Once I substitute 4 by 9 into delta O, I can write the next step delta O as 8,000 into 9 by 4, which give us the value of 18,000, which is option B. So this is another important formula, and this works once you know how it works. The central metal should be the same, only then this formula we can apply. Otherwise, if it's one is cobalt and another is copper, it's not applicable. So you need to understand this well. Next is a question from the biomolecules part. This is by most basic amino acid among the following is the answer is arginine. And why? Because this is the basic classification of any amino acid. There are non-polar side chains, whereas glycine, alanine, valine, leucine, and isoleucine, and even methionine, phenylalanine, tryptophan, and proline are also the same. Out of this, phenylalanine is aromatic, tryptophan can be considered aromatic. Then there are acidic and basic amino acids, which is aspartic acid and glutamic acid, or also known as aspartate or glutamate. And we can say histidine, lysine, and arginine are basic, out of which histidine is weakly basic in the physiological pH. The others are highly basic. Then polar side chains, because there is OH group over here, because of which this OH group, this particular OH group make it the polar side chain, and that is serine. Similar goes with threonine. Then we have cysteine. Then tyrosine again has an aromatic ring over here, but it has an OH, which is a polar side chain. Asparagine, which is similar to aspartic acid, but here instead of the OH group, you have it's an amide group. CONH2. Here also glutamine also it's an amide instead of the acid. So therefore it is known as glutamine and asparagine. So this is the classification of the amino acid, and it will be very helpful if you are trying to remember these, because biomolecules one question is always sure in any PG level examination. One, it can be from proteins, it can be from nucleic acid, or it can be any others, but one question is always sure. So I will discuss one question over here on pericyclic reaction now. So the major product formed in the following reaction is, so you know this is like 2,4,6 octatriene, and this is thermally favorable reaction. There are two ways in which we work on this. So there is thermal and there is also photo reactions. So this is 170 degrees. So this is thermal reaction and electrocyclic reaction. So we have to look at this in that way, and we know that these two CH3 are now facing outward. So there are two possibility in which we can explain this. First one, when the CH3 and the CH3 are facing outwards, this is how the changes happen, and it will give you in the same plane, the methyl group in the same plane. And the other case, if one of the CH3 was actually facing inwards, one will be on the top and one will be below the plane. So the stereochemistry is different. And why is it so? I know this image is not that great in quality, but I hope you can see all this. Like, you know, in this reaction, it's in the presence of heat, this rotatory motion of the orbitals are taking place. So this rotation means both of them are moving in the opposite direction. So this is the direction in which they are moving in order to form the bond. So in the case of CH3, while this rotation takes place, they both remain on the same plane. But if one of them were actually facing inside, as soon as this rotation happens, they go to the plane below. So that is why it is known as the answer for this question will be option B. So to know more about the pericyclic reaction, I am doing one video wherein I talk about all the prominent examples and the concept, which will help you to go through this question more well. So right now, we have started the revision, and in the coming days, I'll try to make more videos with a mixture of concepts where I can solve at least one from every different chapters, so that you'll be covering that portion when we solve this particular question. And even when I'm inactive, many of you have stayed together. So Thank you for that. I'll try to help all of you as much as I can according to the time I have. Thank you so much for listening. And if you have any video requests, please write in the comment box below. I will also give the link of the playlist of all the Cusat related videos that we have done in the in the description box. Please go through that. And all the best. Keep preparing and have a great time, all of you. Bye. See you again.